Well, ladies and gentlemen, we have a big night ahead of us. We are going to tackle the chain rule. Now, this might take us a few days to get down, and that's okay. We're going to practice several days with this. But take good notes. Remember, pause, rewind when you need to, and good luck. So the chain rule is the method we use to take the derivative when we have a function inside another function. And this is going to be our most common derivative. We're going to see this quite a bit. So here's the rule. The derivative of f of g of x. So hopefully you can see g of x is sitting inside of f of x. So the rule is f prime of g of x times g prime of x. So what I like to say to myself is take the derivative of the outside, keep the inside, and then take the derivative of the inside. And again, lots of self-talk. Keep saying it to yourself. Derivative of the outside, keep the inside, derivative of the inside. Some other keywords that are important to me are the words of and the quantity. For example, when I say f of x, that's implying chain rule. Anytime you use that word of, and that's why it's important to read it out loud to yourself. Or when I say the quantity, for example, this is the quantity 2x plus 3 cubed. So the more you practice reading it out loud, the more you'll notice the chain rule that needs to be done. So the first thing I want to do is identify that I need to use the chain rule. Basically, I have an inside and an outside. And I think it's clear the inside is in the parentheses, and the outside is this number 4. Okay, so identify who's inside and outside. Now, I'm going to take its derivative. The derivative of y, of course, is y prime. The rule was the derivative of the outside, keep the inside, derivative of the inside. So I just say to myself, the outside is a power, so I'm going to use power rule to take its derivative, which says bring down the 4. So I'm taking the derivative of the outside, leave the inside. Okay, now that power rule turns that exponent, I have to subtract 1, so I get a 3. Now I'm going to multiply by the derivative of the inside. So the derivative of this inside, x squared plus 5x minus 3, is 2x plus 5. Now, my last goal is to clean it up and just ask myself, what can actually get multiplied together? Because this is to the third power, I can't multiply it by anything. But I can multiply the 4 and this term together. So I'm going to say my y prime is, let's say, 8x plus 40, plus 20, times x squared plus 5x minus 3 cubed. So again, I can't multiply anything by this term because this is raised to the third power. And that's all I'm left with, and I'm done. Number 2, f of t equals 2 cosine of 4t cubed. So sometimes you need to be smart when you read this, and we should know that this says of 4t cubed. They're not going to put parentheses in. You need to do that yourself. So when you read it and you say the cosine of, put your own parentheses in. Now it's clear who your inside and outside is. Because we put our parentheses in, this is our inside, and our cosine, 2 cosine, is on the outside. Okay, so identify the inside and outside. So the derivative of f of t is f prime of t. Okay, remember I'm saying derivative of the outside, keep the inside. So the derivative of 2 cos x, well, it starts with the c, so its derivative is negative. 2 is just a coefficient. 2 sine, keep the inside. Now the derivative of the inside, the derivative of 4t cubed is 12t squared. So at this point again, I just want to clean it up and ask myself, what can get multiplied together? Well, this coefficient can get multiplied by this term. So I'm going to say it's f prime of t equals negative 24t squared. And then I have the sine of 4t cubed. All right, number 3, we have the quantity 1 over 5x squared minus 7 to the 5th power. Now in this case, I think it's easiest to rewrite this function first. So I'm going to say this is f of x equals, I can easily move this up by raising it to the negative 1. So I'm going to say that's 5x squared minus 7 raised to the negative 1 power, and it's all of that to the 5th. Now watch how easy this is. Power to a power says you simply multiply those. So I've got the quantity 5x squared minus 7 raised to the negative fifth power. Now I can easily take the derivative and I can avoid quotient rule here. So I have an inside and an outside. Derivative of f of x is f prime of x. Remember, derivative of the outside, keep the inside. My outside happens to be a power, so I'm going to go power rule. Negative 5, keep the inside. Raised to the, subtract 1 gets me a negative 6. Now take the derivative of the inside. I got 10x. Lastly, I just want to clean this function up. So I can say to myself, this chunk here, because it has a negative exponent, is going to turn into the bottom of my fraction. So my 5x squared minus 7, all raised to the 6th. And these two pieces I can multiply and leave in the numerator. Negative 50x. And there you have it. We avoided quotient rule just by rewriting the function first. Now, we're actually going to do this next problem two ways. I'm going to do it once with the quotient rule and once without. And again, you're welcome to choose whatever works for you, whatever you prefer, but we'll take our time doing both. So, quotient rule. I have a function in terms of x divided by a function in terms of x. But read it first. This says the sine of 3x. So right there, make sure you catch that chain when you said the word of. Here I have an inside and an outside, so I've got chain rule again when I take that derivative. Alright, so let's slowly take the derivative here. Lots of self-talk. Remember, it's low d high, so I'm going to rewrite my low. I'm going to leave a space for my d high for the moment. Low d high minus my high times my d low, which I'll leave a space for at the moment, all over my low squared. Alright, now if it's easier, just take the derivatives separately. If I was to write the sine of 3x, could we easily take its derivative? Well, the derivative of the outside is cosine. Keep the inside. Derivative of the inside is 3. So that's what I'm going to put here. I'm going to say this is 3 cosine of 3x. And I'm going to do the same with that denominator. I'm going to take the derivative separately. If I said 2x plus 5 to the fourth, watch that chain. I've got an inside and an outside. I'm going to say that's 4, 2x plus 5 to the third times 2. So I'm going to say this is times 8, 2x plus 5 to the third. Alright, I'll keep cleaning up here. Now, I happen to notice that I have a GCF in the numerator. What do you see that's the same on, and again, I'm just staying on each side of the minus sign. On this side and this side. What do they share the exact same thing of? Well, I would say I could pull out a GCF of 2x plus 5 raised to the third. Remember, pull out the smaller one. I have a fourth and a third. I can take a third out of both. And then I'm left with, if I take 3 out of there, I've got just a 2x plus 5 and a 3 cos 3x. Then I have that minus sign. I took that out completely, so I'm going to say 8 sine of 3x. All over the quantity 2x plus 5. Remember, power to a power is multiply, so to the 8th. And then I basically have one more step after that. I can reduce this. There's 3 there. I can take 3 out here. So I really have that to the 5th power. And there you go, there's my final answer. Just want to take note, I'm going to always pull that constant out front if I can. I could multiply that 3 through if I wanted to, but at this point I'm just trying to match up my multiple choice answers. Now, I actually wanted to do the same problem, but this time avoid quotient rule. And let's go with product rule. How can I avoid quotient and do product? Well, I could simply rewrite this function and say it's the sine of 3x times the quantity 2x plus 5, and to bring that up, I just have to raise it to the negative fourth. So this time I'm avoiding my quotient rule and I'm doing product instead. But still note, this is the sine of 3x, so I still have chain, and this is still chain. So this time I'm saying the first term times the derivative of the second. So I've got negative 4, 2x plus 5, subtract 1 to the negative fifth, times the inside is 2, plus 2x plus 5 to the negative fourth, times this guy's derivative, which is the cosine of 3x times 3. I'll pull that 3 up. Now at this point, to me that derivative was a lot easier. I still have to pull out a GCF though, and that's where it gets a little sneaky. Remember, when you pull out a GCF, you're always pulling out the smallest, so to speak. For example, if I said x to the 5th plus x cubed, am I pulling out the 5th or the cubed? Well, the GCF would be x cubed. That's the greatest I can take out of both. So I'm picking out the smaller, so this 2x plus 5 they have in common, but who's smaller, to the negative 5th or to the negative 4th? Well, negative 5 is smaller. So as I pull that out, I need to take out the 2x plus 5 to the negative 5th, and then carefully rewrite what's left. So if I take that out completely, I would say I'm left with negative 8 times the sine of 3x plus, now when you take this out, watch what I do here. When I take out this x cubed in this term up here, what am I left with? What does this term become? X to the second. And most people are pretty good at that. Remember, you subtract the exponents. You take what you have and you subtract out the 3. So if I take what I have, negative 4, and I subtract out the negative 5, I'm actually left with 1. So I would say I have 2x plus 5 to the first times 3 cos of 3x. And now, if I just rewrite that, I should get exactly what I had in the other problem. This moves to the bottom, so I've got 2x plus 5 to the 5th, and I'm just going to rewrite this. Negative 8 sine of 3x plus, I'll pull that 3 out, times the 2x plus 5. It might be in the reverse order, but it's the exact same answer. So it's your choice if you like quotient rule or you prefer product rule. Alright, next example. Remember, it's all about rewriting. I would rewrite this as the quantity 2t cubed plus 3t, all raised to the what power? If that's a cubed root, I'm going to raise this to the 1/3. Now, if t's bother you, by all means, call them x's. You're going to see t's a lot this year. So just take note, we have an inside and an outside, so I've got to go chain rule. Why don't you pause it, try it on your own, and see if you get the same derivative. Well, there's what I've got, and I'll work on the cleanup step next. Remember, just make sure you subtract the 1 to get that negative 2/3 there. And here's what I'm saying to myself. I'm just going to go through and ask myself, where does each term sit? Well, 1/3, obviously the 1 goes on top, 3 goes on the bottom. This term has a negative exponent, so I'm going to rewrite it on the bottom. And I'm going to say that's the cubed root of 2t cubed plus 3t squared. And this junk has a positive exponent, so it's going to stay on top. 3t squared plus 3. And lastly, I could simplify it one step. I could pull out a GCF here of 3. So if I pull out a 3, I'm left with 2t squared plus 1. Those 3's can cancel. So I would say I get 2t squared plus 1 all over the cubed root of 2t cubed plus 3t squared. And there you go, a nice friendly one. Alright, next one. H of x equals the cosine of x squared times the sine of pi x. Notice how we read things correctly. Of. Put your parentheses in there. Alright, so let me say it again. It was the cosine of x squared, so I'm going to kind of bracket that in, times the sine of pi x. So I see product rule because I read times, and I see two chain rules because this guy has an inside and this guy has an inside. Alright, so let's talk her out. H of x, product rule. Rewrite the first times the derivative of the second. So if you've got to write it off to the side, that's okay. The sine of pi x. Okay, I've got my derivative of the outside, it's cosine. Keep the inside, derivative of the inside. Well, if that inside said 4x, you would know the slope is 4. So if it says pi x, the slope is just pi. Plus the second term, sine of pi x, times the derivative of the first. So if I have cosine of x squared, remember derivative of the outside, so I'm going to say, whoops, I'm running out of room, times negative sine, keep the inside, times the derivative of the inside. Alright, so I got a little sloppy there. So my next goal is to see, does this side of the plus side and this side of the plus side have anything in common? Is there a GCF you can pull out? And hopefully you're saying, no, I don't see one either, so I'm just going to neatly rewrite this. Just remember, coefficients come up front. So I'm going to say h prime of x equals pi, and I'm going to say the cosine of x squared times the cosine of pi x. Notice this is a minus, and I can pull that 2x out, so minus 2x sine of pi x sine of x squared. And that's really all I can do, nothing else there. Alright, I promise just a couple more. Given that f and g are differentiable functions, all that means is you can take the derivative, alright, nothing else. And we have these given values. The function h is given by this, find h prime of 0. So again, all I have to do is take this guy's derivative. Read each term carefully. G of sine x, bam. The second you said of, that's an inside and outside, and that's a chain rule. 5x times cos x. There's a product rule, two functions being multiplied. So let's take our time. Start with this first term. Derivative of the outside, g prime, keep the inside, times the derivative of the inside. Then we've got a nice plus sign. Now we said product. We have 5x times cos x. First, derivative of the second is negative sine of x plus the second times the derivative of the first. If you got that derivative, you're in amazing shape. And now I just have to carefully plug in 0 to all my x's. So it's g prime of the sine of 0, cosine of 0, plus 5 times 0. Well, this is beautiful. I have 5 times 0 times sine of 0. But the second I plug a 0 in and multiply, that just kills those terms. So I'm going to say plus the cosine of 0 times 5. Now just be real careful. This is the one we got to watch. What is the sine of 0? Hopefully you know it's 0. But now it's not g prime times 0. It's g prime of 0. And what is g prime of 0? Well, they told us that is negative 2. So I've got negative 2 times the cosine of 0, which is 1, plus the cosine of 0, which is 1 times 5. So plus 5, I get a nice answer of 3. Lastly, we're going to tackle the double chain rule. So let's say we're given the function y equals sine squared 4x. Now remember, it's all how you read it. I'm going to rewrite this right off the bat. This is the sine of 4x. And now who's being squared? Am I squaring the 4x? Do you see a squared on the 4x, or do you see a squared on the sine? Well, the sine's being squared, so I'm going to bracket this in and square it. Okay, and it's all about how you rewrite it will make your math a lot easier. Now, what do I mean by double chain rule? Well, clearly this is on the inside, right? But I have another inside, and this is my outside. So because I have two insides, I have to do a double chain rule. So watch how this is done. I'm still going to say derivative of the outside, so that's my power rule. So I'm going to say y prime equals, bring that power down, keep the inside. The sine of 4x, all raised to the subtract 1 first. Okay, so I did my outside and I kept my inside. Now I go to the next inside term, which is this sine function. Okay, so now just picture this is your new function, the sine of 4x. Derivative, here's my outside, here's my inside. Derivative of the outside is cosine. Keep the inside. Now times the derivative of that inside, which is 4. So if I lost you there, pause it, rewind it, and try it again. And lastly, I can multiply this 2 and 4, so I can say that's 8. Sine of 4x, cosine of 4x. Alright, one last one to practice with. Y equals cosine cubed of 8x squared. So again, pause and rewrite it. I am saying it's the cosine of 8x squared, and the cosine is the one that's being cubed, so I'm cubing this whole cosine term. Okay, so it's all about that rewrite. Now we'll carefully take the derivative. So I've got an inside, I've got an outside, but remember I've got this double inside. So start on the outside. Derivative of the outside is power rule. Keep the inside. All raised now to the second. Okay, now I'm going to rewrite my inside down. That was the cosine of 8x. Here's my inside, here's my outside. So the derivative of the outside is negative sine, keep the inside, times the derivative of the inside, so times 8. And then it's just the cleanup part. So I would say this 3, this negative sign, and this 8 go together. So I get negative 24. Now watch how I rewrite this term. I'm going to say that's the cosine of 8x squared. Now does that squared go back onto? The cosine term. And then the sine of 8x. Well, there you have it. I know that was a lot of practice. Be patient with it, and it will start to come more natural to you. We will practice a lot of this. So have a great night, and we'll see you tomorrow.